Good evening, everyone. This is Damian Carlson with the vBrownbag US edition. It is Wednesday, November the 4th, 2015. Our guest tonight actually is Tim Patterson. He is at PC Professionals on Twitter, and he'll be talking about Amazon Web Services, IAM, and Directory Services. I believe that stands for Integrated Authentication Management, if I'm not mistaken, right, Tim?
Identity and access management, pretty close.
I was totally wrong. I had management right, but 33% is a majority, right? So just some quick notes before we get started. You can get in on the conversation anytime by tweeting at vBrownbag or tweeting the vBrownbag hashtag. We also have a number of other podcasts or webinar properties that run around the world. We've got vBrownbag Latin America, as well as vBrownbag EMEA. You can always take a look at our webinar schedule, as well as links to previous webinars by going to professionalvmware.com/brownbags. We also have a YouTube channel. Just go to youtube.com and search for vBrownbag without the hashtag. I would tell you the link, but it's a lot of gobbledygook, so I will not. Again, my name is Damian Carlson. I'm 6foot on Twitter. Our guest tonight is Tim Patterson. He's at PC Professionals. You know what? I totally forgot it. Just a quick note. This past month and a half, we've done a ton of vBrownbag live tech talks. We did some at VMon in Vegas recently. We recorded a whole bunch in at the OpenStack Tokyo Summit, as well as VMworld EMEA. All that stuff is live on our YouTube vBrownbag channel. So I believe that's it for my talking. If you have any questions, just feel free to tweet vBrownbag or tweet the hashtag, and I will go ahead and turn it over to Tim.
All right, thanks,
Tim. I'm making you presenter if you just want to introduce yourself and take it away.
All right. Hopefully everybody can see my screen now.
Yes, sir.
All right, so tonight we're here to talk about IAM and AWS Directory Service. As Damian pointed out, I'm Timothy Patterson. I'm a Principal Cloud Architect. I'm currently working for ProQuest LLC. We're based out of Ann Arbor, Michigan, and we are still in the transition phase, 50-50 VMware and Amazon. So in my daily role, I bounce back and forth between the two worlds. So let's just jump right in. Why are we here? Tonight we're here to learn about the identity and access management component of Amazon Web Services, as well as the Directory Services service. The two kind of go hand in hand, even though they're two separate components. So what will we cover tonight under IAM? I'm going to give you a really brief history lesson to show you why IAM is a good idea. We're going to step through a brief intro, some of the best practices around it. Throughout all of the conversation tonight, I plan on flipping back over to a live Amazon console and showing you the actual screens and configurations as we go. I'm a very hands-on learner as far as a visual strategy goes, so I'll pass that along to you guys. The AWS Directory Service, we'll step through an intro with that, and that can actually run in two different modes, so I'll explain the differences and go through each one. And at the end, I'll give you a few tips on where to go for some more information. This slide I like to show just because it kind of gives a really good visual as to where these services we're talking about fit in. So the identity management component is under administration and security. And if you look at this going bottom up, this is kind of the whole stack of services that Amazon has built. And you can see that identity management and access control in the third row up there are pretty foundational services. They come right after your infrastructure and your networking and storage and compute, basically. So security is definitely baked into AWS from the ground up. And then all the way up at the top here, the second from the top actually, under Enterprise Applications, is kind of where the Directory Services component falls in. And Directory Services helps power the virtual desktop, the Amazon Workspaces service, as well as the sharing and collaboration with the used to be called Zocalo, now it's WorkDocs, and their work mail service as well. So even though we're at different points in this stack, you'll see how the two fit together. And this slide shows a really good timeline of when these services were introduced. So IAM actually came out in 2010, and AWS really kind of got going, I would say 2007, 2008, and then they've just continued to grow from there. The directory service that we're looking at tonight just debuted last year in 2014. I believe that was along the time of their reInvent conference. So let's look back at what life was like before we had IAM. So before we had the identity and access management, the only way into an Amazon Web Services account was through your root level credentials. So those are the credentials you set when you first sign up for AWS, and there was no way of assigning users, groups, and permissions. You had to share the credentials amongst others in your organization, and it was also before the wonderful service that's called CloudTrail was invented. So there was no auditing trail really. You can see by the little meme I put up there, we put post-it notes on, or passwords on post-it notes, and that's just the way of the world before IAM came along. So it was absolutely crucial for Amazon to solve the access management portion of their service. We've already went through what it stands for, but IAM really enables you to control the access to the different AWS services and resources for your users. You can jump right in, you can go very granular with your permissions, you can go very broad with your permissions. But IAM fundamentally enables your security best practices. What do I mean by that? You can stick with a least permissive model for delving out permissions across your environment. Basically, IAM restricts, or you are allowed to specify which services users have access to. We could say that Jim Bob is allowed to launch new EC2 instances but not terminate them. Is just an example of the granularity we can get to. We can restrict calls right down to the API level with IAM, and we'll go through this as we go on tonight. IAM is secure by default, so by default you get no permissions in AWS as an IAM user. You can think of it as like a firewall rule that has an explicit deny at the bottom of the set. So you have to explicitly allow access to the different components and services within AWS in order to grant a user permission. So IAM also lets you create roles. So not only can you manage users through users and groups and attaching permissions to them, but there's another concept here called roles. And roles allow you to define a set of permissions, and then you can let authenticated users or EC2 instances assume them. So I'm planting the seed with this one. We'll come back to this topic a little bit later, but you'll see how it all fits together in the bigger picture. Roles just grant temporary access to the resources you define. So users can be assigned a standard username and password, or an API and access security key pair. So your API key pair is also used for your command line tools, whether it's through Windows PowerShell or through the Linux command line. You still need an access key and a secret key in order to actually do anything, as well as all of your SDK programming languages. Users can actually be authenticated via existing identity systems. So you can actually federate access in from your corporate Active Directory as well as external identity providers like Google, Facebook, Duo Security, Okta, any kind of SAML type provider can be used to grant access into your AWS account by setting up a trust. MFA is fully supported and definitely highly encouraged. Multi-factor authentication can be used either with a soft token, so like Google Authenticator or any of the others that are out there, or you can actually purchase a hardware token to use with your Amazon account as well. And IAM is integrated into most of the Amazon services, if not all of them. So it gives an admin the ability to define access from one centralized location in the management console, and that takes effect throughout your entire Amazon environment. So how do I use IAM? And there's a couple of constructs here that I really want to call your attention to. So IAM permissions are defined and delegated via policies. So you have permission objects and you have policy objects. Permissions let you specify who has access to the resources and what they can do. Every IAM user starts with no permissions, and like we said, by default, they can't do anything. They can't even view their own access keys. So to give a user permission to do something, you can add the permission to the user, you can add the permission to the group that a user is in, or you can fall back to the concept of roles that we'll talk about later. So we mentioned that you have permissions. There's also a construct called a policy. And policies are nothing more than JSON objects. It consists of one or more statements, and each of which describes one set of permissions. So within a policy, you get to specify 4 different areas. You specify the actions, the resources, the effect, and the conditions. An example of an action is what you're allowing the user to do. So the example on the slide here is you're allowing a specific, or you're saying that this policy allows a user to list a specific S3 bucket. Resources, what resources do you allow the action on? So we have allow as our action. Resource will be your specific S3 bucket, whether or not to allow or deny access, and conditions. We'll step through this in a real life example here. So this is an example of an IAM policy. And this policy basically says, hey, we're going to allow access to the S3 bucket called example bucket, and you can only use the S3 list bucket API call against it. It's a very simple JSON statement. I highly recommend you, when writing statements like this, if you're doing it by hand, you use some kind of linting tool, such as jsonlint.com. A lot of your text editors have it built in as well. So you might be thinking, based on this, okay, we've got an action, S3 list bucket. Resource is pretty self-explanatory. Every resource in Amazon is assigned what's called an AR, a number, Amazon resource number. And it's just this long string that specifically identifies a resource. It can be an EC2 instance, an EBS volume, an S3 bucket, anything in Amazon gets assigned an ARN number. And you can view all of that through the console. But the real trick here is knowing what actions are available so that you can actually create policies against it. So you can either take the hard way and look up all of the individual services APIs and code everything by hand, which I don't think anybody out there does, or you can use some of the great tools that Amazon has built for us. So Amazon has actually given us an IAM Policy Generator, and it walks you through step by step in creating an IAM policy. It lets you pick your resources basically in a drop-down type style. And Amazon also offers a very large plethora of pre-created policies. So they've created policies for the most common scenarios, and you can either use them as is, or you can copy them and force them into submission for your use case. And what I want to do right now is just quickly hop over to the IAM console. So when you first hit IAM, you're greeted with a dashboard-like screen. You get this nice little security status at the bottom that lists some of your best practices, and you can see I'm not even in compliance at this moment. This is a newer Amazon account, and we'll get back to that in a little bit, but along the lines of policies. So here are the policies that Amazon has created for you. And there's 167 of them. So if you just look at some of the descriptions, if I can get that to expand a little bit, so Amazon EC2 service or container service for EC2 rule. So Amazon builds out different policies that you can use as an example. You can modify them however you want to accomplish whatever you're trying to do. But what I really want to show you is this nifty little policy generator. So if you're stumbling through, you're new to IAM, you don't know what the heck you're doing, and you decide, hey, I want to give our user Jim Bob access to the S3 bucket for his cat pictures. So we would go allow Amazon S3, and from here you can see all the actions. You can get very granular and individually pick these as you go. So we can give him access to get objects, to get their ACLs, and to get their versions, but nothing else. So you can grant read-only style permissions. You can grant full admin permissions by selecting all actions. Then the ARN you have to pull up based on whatever you're trying to give access to. And just as an example, we can look at an S3 bucket here. It cooperates with me. Here's a backups. We'll just look at the properties here. Look at permissions. Maybe this was a bad example. The Amazon documentation does show you how to specifically identify resources by the ARNs, and the command line, whenever you list out buckets, also shows their ARNs. Apparently they hide that from you in the GUI. That's okay, we can move on. So I mentioned roles before, and I really want you to know your role. So know what roles can do. We have warm fuzzies about being able to use users and groups to assign policies and permissions. But I want to talk about roles before I jump back to the console. So roles can be created. You attach your policies to a role, and then roles can be assumed by both users and EC2 instances. So what do I mean by this, and what does it accomplish for you? And to kind of paint the picture a little bit, I want to give you a scenario. So imagine you're launching a web server that needs to access assets that you have stored in a specific S3 bucket. How would you go about accomplishing this? Would you embed your access and secret keys into your instance? Would you use a configuration management system to statically set those keys within an instance? Or would you use some other kind of witchcraft? And the answer is none of those. Never, ever embed your credentials into an application config, an EC2 instance, or a configuration management system. There is a better way. Why do I say you should never do this? There was a company called Codespaces a while ago, and that company was basically a GitHub-style website with some premium features that were offered. And they had excellent security as far as network and application layers go, but they had keys embedded in some files that got pushed up to a public repository. A hacker was able to obtain those keys. They basically held their website ransom for a few days. Codespaces did not realize how they actually got into their account, and then the attacker was able to completely wipe them off the map by deleting everything right through the back door. They had full access because their keys were compromised, because the keys were stored in an application file that got pushed out to the web. If you go to codespaces.com nowadays, you see they're simply pointing you to SVN Lab and Bitbucket. Their company went bankrupt after such a disastrous leak of your credentials. So how should you go about storing your credentials? You can use a role whenever you need to allow an EC2 instance access to other AWS resources. So going back to our scenario, the best method to allow access to an S3 bucket is you can create a policy granting access to a specific S3 bucket or buckets as needed. You create a role, name something like, hey, let's allow access to our cat pictures S3 bucket, and then you would attach that policy to your role. When you launch an EC2 instance, you can actually choose which policy, or which role rather, you want to assign to an instance. So that instance then automatically inherits those permissions that you had given to a role. And the roles behind the scenes are rotating your access and secret keys for you on a very short-term basis. So I think it's something like every 5 minutes the keys get rotated. And those keys are automatically passed through to the SDK tools, your CLI tools, all of your standard interfaces with the Amazon services automatically pick those up within an instance. You can also manually retrieve those keys with a call to the EC2 metadata service, which is just a simple curl command in Linux, or it's a REST endpoint for any Windows programmers, and you can just hit that and it will spit your keys out and continuously rotate them for you. So it's a little bit more secure there. And flipping back to the console a little bit, I just want to try to glue all of this together. I realize I'm trying to be somewhat quick covering these topics. So we have our typical users, roles, and policies. You can create a user. All you need is a username, and each user will get an access key and a secret key. Once you create a key, security credentials, you have one time to grab your secret key, and like I said, access and secret keys are used for API access or command line tools access. So access key is kind of like a public key, and your secret key is definitely just that. It's a secret. You should never share that with anyone. A user can also be assigned a username and password for access to the web console that I'm on now. And you don't have to grant username and password. You can strictly rely on your access and secret key, and vice versa. You can not have an access and secret key, but only have a web console key. You can turn on MFA for any user. Signing certificates are starting to be deprecated slightly. They're still valid today. That's how you used to be able to do things before access and secret keys came along. You would actually have to create a certificate for yourself and use that to authenticate to the API endpoints. This is a new set of security as well. You can upload SSH keys specifically for the AWS code commit service. That's their code repository. You can attach policies directly to a user. You can create an inline policy that's only allowed with that user. I tend to stay away from anything inline. It's better to create the objects and attach them than it is to specify them right on the resource. It's no different than choosing groups over individual users to assign permissions to in something like an Active Directory. And then here you can see that this user is getting a policy through a group. So groups, you can create them arbitrarily. You assign users into those groups. And then if we want, we can actually attach policies to those groups. So here's an example of a policy that's allowing this group to do anything with a Glacier service. One thing I do also want to point out, and I think I have this listed in my slides under advanced topics. This is a recent addition by Amazon, and it's called the IAM Policy Simulator. So as you're building out these policies and you want to see what the effect is going to have on an individual user, you simply come in here to the policy simulator and you can pick your service. You can see, okay, can a user delete a vault, for example? Well, this time I'll just go delete archive since it's chopped off my screen with a smaller resolution here, but then you can see run simulation, and it is allowed. And the reason that's allowed is because we're allowing all actions. So Glacier : wildcard. We could say, no, we only want them to be able to list archive. Run the simulation again. That's an invalid policy. One action, abort vault log. Apply. Now we'll run our simulation, and it's denied because this policy does not allow users to actually delete an archive. So by using the policy simulator, you're able to go in. You can copy paste your policy into this little column here on the left. As you see, a bigger screen usually helps. You can apply the policy to the simulator, and then you can run simulation against all different actions, and you can actually see precisely how your policy is going to play out in a live environment. Roles. Roles are created in much the same way as a user and a group, but there's a few caveats here. So roles have different types. You can allow EC2 instances to call other services on your behalf. This is what I was talking about, where you would allow access to an S3 bucket. You can allow directory service to manage access for existing users. We'll be coming back to this in a little bit. Some of the other services have direct hooks into roles here. Those are mainly advanced topics. One thing I also want to point out here is roles for cross-account access. So if you have multiple AWS accounts, or if you have a customer that needs access to assets in your Amazon account, you can actually set this up using a role. You can allow access between Amazon accounts. You basically establish a trust by stepping through these wizards here. It's very straightforward as to how you do it. If we were to continue down this path, it would ask you for the account ID, which is unique for every Amazon account, whether or not you want them to use MFA, and you can attach policies to that as you go along as well. So you can specify exactly what somebody could get to. You could lock them down to an individual file in S3. You could lock them down to only being able to read what instances you have running, so on and so forth. If you dream it, you can apply it. And then we had already talked about policies here. Any policy that has this little logo here is managed by Amazon. Any policy that you create does not have that icon with it. And we've come full circle here back to the policy generator as to how you create those. So some IAM best practices. These are best practices that are pretty widely advertised within the AWS community, and they're pretty standard. I mean, enable MFA on your root AWS account. And I would even take that a step further and say that you should not even use your root Amazon account for anything. That's the account that is tied to a specific email address when you first sign up for Amazon. Best practices are dictating from then you create your IAM users, groups, and roles, and then use those for day-to-day administration. The root account is very dangerous in the fact that IAM policies do not apply to the root account. The root account is always a global administrator, and there's no stopping it from doing anything within your Amazon account. So enable MFA on that, use a hardware token, store it in a safe place, and forget about it. Don't ever use it unless you absolutely have to. Stick to the least privilege model whenever you're delegating permissions. This is no different than any other kind of service that we run across our organizations. I also encourage you to enable MFA on your IAM accounts, and I suggest that you do this both for the console and for the CLI. It's the same sort of interface. There's no reason not to use MFA. I know sometimes it can be a pain in the butt, but at the same time, it gives you an extra layer of protection, because on the bottom here, not to skip around too much, but you do not want to be the next code spaces. Don't go all in with a cloud deployment and then get wiped off the face of the planet because of a leaked credential. You can have the best network security, the best application security. It doesn't matter. If you're giving somebody keys directly into your Amazon account, you're done for. And that's just another attack vector that we have to protect against in today's world as we move into more cloud services. That applies no matter what your vendor is per se. Regularly rotate your access and secret keys. So when we were back on the Amazon console, looking at an individual user, you can see that under their security credentials, you can actually create more access keys. I can show you my credentials here. So if somebody was quick enough, they could grab my credentials right now and log into my Amazon account, but then you can also go right in and delete the key. So you can rotate keys. You can have quite a few keys in your list. They can all be active at a time. You can make them inactive, or you can flat out delete them. Just best practice says, hey, let's keep rotating these things. Let's not let them linger for too long. Define and use password policies. Yes.
Quick question from Grant Mitchell. He wants to know if you can delete your default root account and create a new admin root account.
No, unfortunately, that's actually something that you can't do. And to be honest, there isn't really a reason to use your root account for anything. Once you log in with a brand new account, like I said, you should create an IAM, like an administrator group, and give that group all permissions. That way you can stay on top of things and then start delegating from there. Your root account is really only used for initial setup of your account. It's kind of a legacy thing, and right now it is unfortunately impossible to change that root account. Now, you do have the option to rotate keys in the root account. You can enable MFA like we're talking about here. But as far as I know, it's not possible to create a new root account for anything in Amazon. Amazon support might tell you otherwise, but it's not widely known if that is the case.
Okay, thank you.
Yep. Another no-no is don't get in the habit of creating service accounts or IAM users dedicated to a task. So going back to our example of needing to grant an application access to an Amazon resource, whether it's an S3 bucket or anything for that matter, use roles for that. Roles give you the automatic key rotation. It's fully integrated with all of the SDKs and CLIs. By default, that's where they look first for their credentials before they even look at a config file. Whenever you create something static, the chance is there for somebody to compromise those credentials, you not rotate them soon enough, and then you're stuck. It's just a really good practice to get in the habit of using roles for everything. And with that said, we're going to hop over and take a look at the directory service. And I had mentioned that these two kind of tie together a little bit. So we talked about federation, and we talked about how you can use a directory to give you a window into IAM. So we'll start by just introducing the directory service from the ground up. So what is it? The directory service is a managed service. It makes it very easy to connect to your existing on-premises Active Directory or to set up and operate a brand new directory within Amazon. So it makes it a lot easier to deploy and manage Windows workloads within AWS. Most Windows workloads nowadays do require some kind of Active Directory integration for authentication purposes. It provides authentication, but it also allows you to define users and groups to access some of the Amazon Enterprise services. So we talked about delegating access right to the management console, but certain AWS apps like Workspaces, their VDI solution, going back to that visual slide I showed you in the beginning, WorkDocs and WorkMail all integrate with a directory service to get their authentication information. So the practical application here is you don't necessarily want to give Jane Doe access to everything within Amazon through IAM, but you want her to be able to use WorkMail, Workspaces, and WorkDocs. So this is where your directory integration comes in. You point those Amazon services at an Active Directory installation for their authentication purposes. The directory service is somewhat unique as far as Amazon service offerings go in the fact that it actually operates in two distinct modes. You have an AD connector mode and you have a simple AD mode. Now I'll step through those here. So let's start with the AD connector. It's the simplest deployment method, and what the AD connector is it's basically a proxy. It's provided by the Amazon directory service. It allows you to connect back to your on-premises Active Directory, and it basically glues that up to the cloud. So there are some prerequisites in order to use the AD connector. So this is assuming that you're using a VPC, which was covered in the last vBrownbag on Amazon. So it assumes you have a VPC, which is just your private island of cloud space. connected back to your on-premises site either via a VPN connection or a direct connect connection. So this assumes that you have some kind of network layer connectivity between on-prem and in the cloud. It does not require complex directory synchronization techniques or the cost and complexity of hosting a federation infrastructure. So the proxy is kind of just a proxy. So when you use the AD connector, you're not actually establishing a replica out in the cloud. It basically just acts as a funnel. So any kind of Active Directory request that's coming in through the AD connector service, it just shoots that back to your on-premises installation and gets your authentication information. You can look up users, groups. You use it just like a normal Active Directory, but it's really just kind of a network pipe that's shipping everything back to your on-premises environment. It's the simplest way to get an Active Directory presence out in your VPC subnets. Everything is there that you'd expect, your existing security policies, password expiration, history, lockouts, group policy. You can join computers to your domain by using this service as a proxy. It's basically just a plug-in to your Active Directory. You can also use the connector to enable MFA by integrating with your existing radius-based MFA infrastructure. So if you're currently doing MFA in your enterprise today, you can tap into that same system to allow MFA access for IAM users and individual service users through the AD connector. And as I mentioned before, the AWS Directory Service in AD connector mode does not replicate any of your directory data. It's strictly just a pipe between the two environments. So with that said, I hope you picked up on this along the way, there is a design constraint if you're planning to use this connector that if that VPN goes down or that direct connect connection goes down, you will lose your authentication ability. There's ways to design around that, such as having active failover VPN tunnels, a failover on a direct connect, things of that nature, but it's something to be aware of as you're designing out a deployment. Now we'll switch to the other mode for the, yes.
What would you say the performance is when you're linking, on-prem AD to AWS?
Sure. So Active Directory is typically very lightweight as far as an LDAP exchange goes, or something for a quick authentication lookup or a domain join. It's typically low bandwidth, latency. It really depends on how you have things configured. So if you're just doing a VPN back to your on-premises environment, you're at the mercy of your internet connections and what region you're connecting to within AWS. So if you're an East Coast business connecting to the West region for Amazon, you're going to have latency there. If you're on the East Coast connecting to the US East region, your latency is going to be pretty quick, provided that your internet circuits can pipe that traffic pretty quick enough. What I typically see within an enterprise environment is if you're considering some kind of deployment like this in like a hybrid cloud architecture, it's not too uncommon to see a direct connect. And what that is it's a dedicated pipe between your organization into an AWS data center. They come in speeds from a gig all the way up to 10 gigabits per second. And like, for example, ProQuest, where I work on a daily basis, we have 2 direct connect 10 gig pipes into the Amazon US East 1 region. So that provides us the failover capabilities that we need. We're actually deployed using the AD. Performance is great. You don't notice a difference. With that said, we have had times when we've had to fail over to VPN due to direct connect maintenance or outages. And in that case, things do slow down a little bit, but they still do continue to function. You're just at the mercy of your internet circuits. So hopefully that answers.
And if you completely lost that link?
If you completely lost that link, you would lose your authentication services for a period of time.
Okay, but
now with that said,
it's not like your VMs would shut down or anything, right?
No. They would not shut down. They just they wouldn't be able to communicate back to your domain controller. There are some hacky ways to work around that. you can spin up an EC2 instance that is a valid Active Directory replica within your VPC using that same connection back. So if that connection were to break, you have a replica. But that is taking you out of the realm of the managed service, and then you're putting the onus back on yourself and managing Active Directory in kind of a more traditional sense.
Right, just like how you would get a remote site or something.
Exactly, and you would still need to use the AD connector service in that case, even if you were hosting your own Active Directory in your own VPC, if you wanted to use Workmail, Workdocs, or Workspaces. Those three Amazon services are dependent on having an AWS directory service of some kind. So even if you were hosting it out there, you would still need the connector. But you could point the connector at your VPC, Active Directory replica, and not depend on that network connectivity going back. Now,
okay,
with all
cool.
that said, we'll transition into the simple AD mode. And this one I think will make more sense for some of the scenarios we were just talking about. So the simple AD is more of a managed service. It's actually a full-blown Active Directory deployment, except it's powered by Samba 4, and that's an open source Active Directory compatible server. I'm sure a lot of people out there who have been in the Linux world in the past 10, 15 years have heard of the Samba project. This is version 4 of that. It's come a long ways. It's really matured and stabilized, so much so to the point where Amazon trusts it to power a full-blown Active Directory deployment for you. It supports all of your commonly used features. It's fully compatible with Microsoft Active Directory, so you still get your user accounts, your group memberships. You can join EC2 instances into the domain and manage those objects. You can join Linux and Windows instances. You can do Kerberos single sign-on, and you still have group policies. So for all intents and purposes, your core Active Directory services are fully complete within this service. Many of the applications and tools you use today that require AD can actually be used with the simple AD service. And this service will power your 3 Amazon Enterprise services, Workspaces, Workdocs, and Workmail. And it also gives you the ability to manage your IAM role-based access into the management console. So you can tie that in as your user source and delve out permissions that way. The simple AD includes, and this is all managed by Amazon, it's hands-off. So you provision a simple AD, and they'll give you snapshot backups, replication monitoring, and point-in-time recovery. So those are all included with a simple AD deployment. And a simple AD deployment is actually standalone. It does not natively integrate with any on-premises Active Directory deployments. Now I say this with a caveat. It is a fully standalone domain. However, you can establish domain trust between a simple AD and on-premises Active Directory. So you could create like a cloud-only Active Directory domain and set up a trust back to a full-blown Microsoft Active Directory domain on-premises. The simple AD service is great for a greenfield AWS deployment. So if you're looking to build something cloud native, push it out to a VPC, and you need authentication services, this is a great solution for you. You can just put it out there. This actually lives within your VPC. There are no dependencies on network connectivity back to your on-premises data centers or anything like that. You still use the tools that are familiar to you. So to manage users and groups, you use the native Microsoft tools, the Active Directory Users and Groups utility. You still use your MMC console to create and manage group policy objects and things like that. It's a very solid service, and it's completely hands-off for you. It doesn't matter which mode you operate in. These next slides will focus on some of the other benefits of using the directory service itself. So it provides the ability to give you directory users and groups access to services and resources, such as the EC2 console. We talked about the federation. To provide this access, you assign IAM roles to your directory service users and groups. And that goes back to the screen I was showing you on the console, where you can do identity providers. So you can tie in with an identity provider You can also create a role that will integrate with directory services. So then within directory services, you attach different roles, and users can then assume those roles based on some of the permissions that you delve out. You can join EC2 Windows instances to an active AWS directory service directory. Doesn't matter if you're using the AD connector or a simple AD. You can also join Linux instances to active directory services using the System Security Services daemon, SSSD in short. The Windows functionality actually has an extra hook within EC2. So as you're provisioning a Windows EC2 instance, you actually have the capability to configure this simple systems manager service that Amazon has created for you that basically lets you define what domain you want to join before you actually launch the instance. And then as the instance launches, it'll automatically join into a domain for you. And the power of that is if your application relies on being joined into an Active Directory domain and you have it wrapped in something like an auto-scaling group, and a scaling event takes place. So your application would load, auto-scaling kicks in and says, hey, we need a new instance. Your instance boots up and it will automatically join into whatever that domain is that you have specified. That's not something that's natively available on Linux. However, you can emulate the same sort of thing through a user data script. As an instance is booting, that user data script gets executed. You can have the proper SSSD commands in there to configure it to auto-join your domain and inherit whatever policies that come along with that. So what to do from here? There's some advanced topics in using IAM. You can use it to delegate resources across multiple AWS accounts that we talked about. We talked about using federation to third-party SAML providers. So you can use anything that supports the SAML standard basically to interface in with IAM. Some other advanced topics include defining organizational standards for naming, organizing, and controlling access to IAM policies and permissions. You don't want everybody to be able to create these things, and you want to keep some kind of organization or rhyme or reason as to how you create these things. It's easy for it to get out of control if you have too many hands in the cookie jar. Just like with any other kind of construct in IT, you need some kind of naming standard and organizational standard. Play around with the IAM Policy Simulator. That's a really cool piece of technology that lets you learn IAM policies hands-on by trying something out and seeing what the cause and effect actually are. I listed the links to the documentation here on these slides for both of these services. A couple other tidbits I wanted to point out that I did not necessarily get into my slides, but let's go back to IAM here. All of your policies now are actually version controlled, which is something new that Amazon has started recently. And it's pretty slick. It was long overdue because managing IAM policies was starting to become a little bit of a nightmare. So I'm just going to create a sample policy here. It's pretty wide open. And you can give all of your policies descriptions and everything here too. I'm just going to go ahead and create this object. So now we'll find it here. Hopefully, let's just filter it. So here's my test S3 policy, and I want to come in and edit it. You'll see that it actually creates different versions for you. So I can edit this. Let's just see, S3 my bucket / that might not be valid. Must be in your format or R. Let's just go EC2 star. So this will grant access to all EC2 bucket or EC2 instances now. Getting there. And this is why nobody encodes IAM policies. Apparently it's being stubborn, but just as an example here, you can see the screen. It would create a new version. You can go through, set your default versions, and revert in case something bad has happened. So that's another good practice to get into, something to be aware about. The directory service, I wanted to show you real quick on how to provision one of those. And it's actually kind of a wizard-based thing. You need to have VPC in existence. This is an account I fired up just for tonight's demo, so it looks like my default VPC is not there. But you can use the AD connector. It basically just prompts you for the information it needs. So you give it some on-premises DNS servers. You provide an administrative level credential that can join a domain. And there's one other permission that's listed in the documentation if you want to grant least privilege there as well, which I highly recommend. Or you can go to the simple AD route, and it will launch the Samba 4 Active Directory compatible server for you and let you manage that as a separate directory altogether. And then where can I learn more? I've listed this on all of the Amazon talks I've ever given. I feel like this is a really good resource or list of resources that you can use if you want to learn more about any kind of Amazon topic. So the Amazon YouTube channel is a top-notch resource. So for example, all of these sessions, I think there were 280 some sessions given at reInvent this past month. They're all online and freely available through this YouTube channel. You don't have to be registered. You do not have to have attended the conference. It's in Amazon's best interest to diverge the information on how to better use their services. With that said, they also post all of their presentations up to SlideShare. Amazon has some self-paced labs, some of which are absolutely free to take and jump through and get your feet wet with some intro-level service integration. The Amazon blogs is a great resource. Anytime there's a feature enhancement, some kind of update to a service, a new service comes out, the blogs are usually the first place that gets that information, and there's RSS feeds and things like that. The AWS forums is a great place to turn if you need community-based help. I've heard rumors that there's a Slack channel starting up, and I've also heard rumors that there's an IRC channel. I haven't really hopped onto either one of those, but those could be great resources as well for community support. Cloud Academy is a great website to go to for any kind of formalized training. So they run tracks on all of the different AWS services. They're mainly geared towards certification, same with Udemy, listed at the bottom there. If you're looking at trying to just gain a foundational knowledge of AWS, I highly recommend the AWS Certified Solutions Architect Associate track. That covers everything we've just talked about in IAM tonight and a basic intro-level understanding to the real core AWS services. And that pretty much concludes our talk tonight. Any questions or comments, you can direct right to me if you want, through Twitter or through email. I'm always available and willing to help when I can. Hopefully you've learned something valuable from this brown bag this evening. And with that said, I do thank the vBrownbag crew for having me on again.
Absolutely. Thank you very much, Tim. This has been very informative. And thank you to everyone that attended live and is also listening afterwards. Feel free to tweet at vBrownbag or the vBrownbag hashtag if you have any other questions that don't pertain specifically to what Tim presented tonight. And with that said, I'm going to go ahead and close it out for the evening. So thank you, Tim, and thank you to everyone else. And we will talk to everybody next time.